Hello and welcome. My name is Gary Winter. In this video, I will show you a structured development methodology for writing code in Microsoft Dynamics 365 Business Central. Our objectives in this course are to learn why we need a structured development methodology for writing repeatable IP and what benefits it brings. How to translate business requirements into Visual Studio Code AL in a structured way, and what principles and elements to watch out for in order to make our code highly understandable across the complete ecosystem of AL developers, updatable and expandable. Let us first discuss why it is relevant to write code in a structured and reproducible way instead of just developing in any individual way we may think of. Isn't it just enough to develop the functionality that needs to be implemented, one may ask? Does it matter how it's written? Well, it does. And it makes the difference between arriving at a true software product with repeatable IP or not. The way we write code significantly influences the transparency, testability, updatability, and expandability of our product. And if we look at the complete life cycle of our solution, this is exactly what we need. We need our code base to be easily understandable for other developers, and that includes us when we come back to our solution after some time. We need it to be easy to test and update to a new version, and we need it to be expandable, if only for customizations in a given implementation. If we write our code in a structured and reproducible way, we minimize the risk for bugs and for things to go wrong when the code base gets updated or when functionality gets enhanced. Doing so, we reduce the total cost of ownership for the product and for any implementation based on the product, and we allow for a wealth of well-defined integration and enhancement scenarios. While a structured development methodology is beneficial for any kind of coding, it is a must for repeatable IP. A structured approach to writing code defines how to transform business requirements into coding elements. It allows developers to select and use these coding elements in a very conscious and reproducible way. Doing so, your development decisions become explainable and understandable for others very easily. While not confining creativity, any randomness in coding needs to be eliminated. Creative coding lies in selecting the right design patterns, extending design patterns, and inventing new design patterns, but not in just writing code in any random way that may come to your mind at the moment. The structured development methodology implements a type of coding which can be taught, learned, applied, and reviewed. There is a standardized approach to translating any business requirement into code. Any business requirement can always be assigned to three elements. Somebody always does something within a given process. So when we come upon a business requirement, we always need to ask ourselves these questions first. Who, meaning which agent, does what, meaning performs which action, in which context. If you think, for instance, of sales posting in Microsoft Dynamics 365 Business Central, the answers are easily found. The sales header, that is the agent, posts, that is the action, from a document, which constitutes the context. We see that the agent, the somebody who does something, is almost always represented by a class, or in Business Central / Visual Studio Code AL terms, a table. The action is a method of this class as reflected in a code unit object. And the context is normally constituted by a UI element such as a page, or alternatively by some background process. You can break down this implementation model into the formula who does what where. This formula has a lot of analogies in communication, such as the 5 W's in journalism as established by Joseph Pulitzer: who, what, when, where, and why. Or the concept of circumstance as defined by the Roman statesman, philosopher, and orator Marcus Tullius Cicero, which is some 1,900 years older. So when you start to put a business requirement to life, always start by determining who is acting. This is almost always a class or a table. Then put any action into a code unit of its own. Finally, always call an action only through its agent. You define a function on its table and make the function call its code unit. Never call the code unit directly from anywhere, but from this function on the table, which declares it as one of its methods. The structure is always record.doSomething, where record is the table and doSomething is a function on the table calling a global function of the same name in a code unit of the same name. This constitutes an object-oriented approach to coding, although Visual Studio Code AL is not an object-oriented language. This is more about your development approach and how to reflect that development approach in Visual Studio Code AL. Although the language as such is not object-oriented, we can get pretty close in implementing it according to object-oriented principles. It is very important to replace the traditional procedural architecture by this approach. We're not running functions or code units anymore, passing record variables as parameters. We're letting a class implement its methods. Classes are normally represented by tables or table extensions. In some rare and well-defined contexts, a code unit can be used as a class as well. Each class always carries all of its attributes and methods. Attributes are the table fields, methods are the table functions, which point to code units of the same name. Just like the attributes, all methods are always declared on its class. This implementation methodology has a lot of advantages. It not only structures your code in a highly transparent way, but it also makes you see immediately and without searching for it which methods exist for each class. And it should be clear by now that which functions exist for each table and which actions are defined for which agents are only synonyms for that. Thus, IntelliSense works not only for every field, but also for all methods of each class. These methods need to be declared, but in most cases not coded on that class. The general principles to be followed on implementing a method are encapsulation, decoupling, readability, and consistency. Let us have a look at what that means for coding any sort of method. Encapsulation is one of the 4 fundamentals of object-oriented programming, along with abstraction, inheritance, and polymorphism. It is all about packing functions which belong to one method into a single component. Doing so, you hide these functions within an object, thus building an impenetrable wall to protect the code from accidental disruption. So, encapsulation is a language mechanism to restrict access to a number of defined components. A more trivial way of putting it would be as local as possible at all times. This is how the principle of encapsulation can be reflected in Visual Studio Code AL. Each method becomes a code unit of its own. The code unit always only has one global function. The method code unit itself does not have any global variables. All variables which need to be shared by functions are passed locally as parameters. A method is always instantiated through its class, which means that there is a global function on the table which declares the method and calls the only global function in the code unit. In code, you always only call the method through this function on the table. Finally, within the method code unit, each local function always only executes one single task. Let us turn to the next principle of implementing methods in a structured way, that is decoupling. Now, the value of decoupling is normally defined in a negative way through the disadvantages of tight coupling. Coupling describes the degree of interdependence between routines. Low coupling is a sign of well-structured software and good architectural design. This principle has been introduced by Larry Constantine in the late 60s in his book on structured design. Larry Constantine is an American software engineer and computing pioneer who has become a professor in the Center for Exact Science and Engineering at the University of Madeira, Portugal. So decoupling actually means providing low coupling. The need to keep coupling of routines and components as low as possible is easily illustrated when looking at the disadvantages of tight coupling. In tight coupled code, a change in one routine forces a ripple effect of changes in other components, thus making routines hard to reuse because all the dependent routines must always be included. It may be a no-brainer to demand that your code should be readable. But what exactly does that mean besides coding in a clean way, leveraging design patterns, and using standardized naming for variables and functions? Well, special attention needs to be paid to the main function of each method. It should ideally be a readable flowchart of what the method does. It should include all relevant steps, wherever that is possible. If you find that this appears to be impossible, you are probably trying to squeeze what should be more than one method into a single code unit. The main function of each method should resemble understandable plain text more than language-specific statements. If you want to break it down into an example, a function called getCustomer is not language-specific, while a statement like cust.get is, because the exact syntax that you need to implement to retrieve a customer record from the database will vary in any programming language. If you want to operationalize what understandable plain text means, just imagine whether it's readable for consultants or non-developers in general or not. Here is an example of what understandable plain text or a readable flowchart of what the method does can mean in practice. This is an extract from a method which batch posts planned costs. See how all the statements only call functions which have a name that does not sound cryptic or idiosyncratic to a specific language. Instead, they could be headlines indicating a sequence of actions which is understandable to any non-developer. The implementation of the methods starts with a few error checks. You can also see immediately how this way of coding helps consultants and support. Imagine a user who contends that there is a bug in the code because it always comes up with an error if the user has not specified a posting date. Looking at this code, you can make the immediate call that this is not a bug, but included by design. There may still be some argument as to whether it is necessary or not, but the way the code is implemented immediately shows anybody who looks at it that the posting date is mandatory by design and that the developer has made a conscious decision about that. You do not need to understand the code as such, and you do not need to dig deeper to be able to make that call. Being consistent is a major quality of any software, and that does not only pertain to code. Consistency is a quality that starts in marketing and ends in the naming of a function. We need to think in terms of consistency from marketing to sales messaging and documentation right down to code level. In this example here, we are making sure that a method which posts accruals is called post accrual on UI level, that is on the page. but that the method on the class is also called post-accruals, as is the code unit, which implements the function and the one global method within that code unit. There are slight variations to these naming conventions. Let's suppose posting accruals is a method which exists in the context of more than one class or data entity, for instance on the sales header and on the purchase header. In this case, you would add that context information where necessary, but omit it where it is not needed. Since you would need two code units which implement the method for the different entities, one would need to be called post-sales accruals, while the other one would be called post-purchase accruals. In the explicit context of each data entity, you would, however, leave out the epithet which creates that context, that is, sales or purchase. So the page action would only be called post-accruals on both the sales order and on the purchase order page. That holds true for the method on the class and the global method function as well. After we have clarified the principles that govern a structured development which places each piece of functional code inside one encapsulated code unit, let us now take a closer look at the internal structure of this method code unit. In general, your code is based on system events or integration events published by the Microsoft Base app, which make its code extendable for you. So keep in mind to make your own code extendable as well, preferably even more so than the current Business Central Base app. Make your code easy to extend for your own dependent add-on apps, for third-party add-on apps which build on top of your IP, and for tenant-specific custom apps written by your reselling partner for a specific implementation. Do so by making every single one of your functions extendable. There are three different contexts to look out for. 1. Wrap every method into onBefore and onAfter events in which the onBefore event implements the handled pattern. This makes it easy to implement a variation of the complete method if that becomes necessary in a dependent add-on or in a tenant-specific customization. 2. Insert integration events which make it possible to enhance your code wherever appropriate. 3. Always separate the initialization of data from database transactions such as insert or modify by publishing an onAfter initialize event before the database transaction. What is the positive effect of that? Imagine that an add-on adds a few fields to an existing table by means of a table extension. The add-on most probably needs to assign values to these fields in all of the instances in which you assign values to the original fields in that table. You will need to enable that by allowing add-on or custom apps to hook into that process by an integration event which you can subscribe to before the data gets written to the database. In quite a similar way, you should think about publishing an integration event whenever you set a filter on a record set that you loop through. An enhancement of your app may want to set additional filters based on new or different fields. I have emphasized earlier that each method code unit only contains one global function. All other functions are local. This global function does not contain any functional code, but only the structure of how the functional code is implemented. It consists of three main layers: a UI wrapper, an event wrapper, and the functional code as such, which gets implemented by the main method. All of these structural and functional elements are local. The UI wrapper consists of a confirm and an acknowledge part. It first asks whether the function should be executed, unless this is suppressed by a high dialog parameter which gets passed to the function, or by the fact that we are in a context in which no UI is allowed. The final acknowledge part of the UI wrapper gives information on whether the function was executed properly and with what result. The UI wrapper is optional. There are a lot of cases in which no confirm nor acknowledge would make any sense. There are also a lot of cases in which just the acknowledge is not necessary. If you include a UI wrapper, you should always include a high dialog parameter to enable the execution of the method with or without a user interface. The event wrapper makes it possible for an add-on or tenant-specific extension based on your app to implement a variation of your method. The onBefore event wrapper publishes a business or integration event implementing the handle pattern. If an extension based on your app subscribes to this event and sets handle to true, the main method needs to respect this and not execute if a variation of the method has already been executed. That is why every main method needs to begin with the statement, if handled, then exit. The main method finally is what has been called a readable flowchart of your method, containing all relevant steps as local subfunctions which have names that resemble understandable plain text. This is an example of what the structure of the global function looks like in Visual Studio Code AL. And here you see the complete structure of a method code unit exemplified in Visual Studio Code AL, containing all of its building blocks. It is more a matter of taste whether you want to place your business extensions before or after the event wrapper. It is also entirely up to you whether you want to implement the event wrapper as business events or integration events. The functionality is exactly the same. Implementing them as business events implies that you will never change the contract established through them. This is probably a very hard call to make. Implementing the wrapper events as business events also sets them apart from the integration events, which constitute an enhancement of your original code instead of an override of your method. This does make some sense, but it is not in keeping with the original definition of how business events are to be used if you do not intend to permanently keep the structure as it is. Finally, let us have a look at the structural elements which make up the main method of a method code unit. Surprisingly, or unsurprisingly enough, you will find that the business process part of a method code unit always consists of the same elements. These are usually elements which perform a validity check, that is, check whether a method is valid in the current context or not, and if not, exit or throw an error. Define a filter. Loop through a number of records. Assign new or modified values to these records, or perform database operations on these records. Any code you write can normally be assigned to one of these element categories. In the light of the fact that one function should only ever be designed to accomplish one task, it is advisable to put all of the code for these elements into separate functions. Have one local function that defines a filter, another local function that loops through the filter, one function that assigns values to a record, and another function that performs the database operations. Also make these reappearing structural elements visible by giving them similar names in each code unit. It will give you and other developments a great sense of structure across your complete code base and help you to arrive at a structured and unified way of translating business requirements into Business Central code. This concludes our course on structured development methodology. We have learned why a structured development methodology is an essential prerequisite for writing repeatable IP, how it can be used to translate business requirements into code, and what principles and elements to look out for and implement. To learn more about how to build and publish apps with Microsoft Dynamics 365 Business Central, follow the link on the screen.